Hey guys, what's up? Eddie Alho here with KissAnalog.com. Alright, I thought I'd just do a little quick video here. I got my Class A Amplifier here, project that my friend was listening to for a while. I took it back to kind of finish up some touch-ups. There's a switch that was broken and things like that. But in the process, I'm not sure what happened exactly, but anyway, one of the op amps failed. And so I might have shorted something, taken measurements. I probably did something like that. Okay? So I bought some more op amps. And I bought a lot of op amps. And you guys may have seen the video where I showed some of the problems with buying things online, you know. Especially when you're trying to buy an op amp that's been discontinued. There's a certain amount of surplus stock that's going to be out there, but after that is gone, it's gone. And then if there's a market for it, then you get the people, you know, in China who are knocking them off. And if they work as well, that's okay. But if they don't, which I found, then that's a problem. Anyway, I've had one setback after another, kind of put it on the side, did some other things. So today I'm doing a little repair work, and I think I got some parts that will work. And so now, just why I ran into the op amp problem. The op amp that I wanted to use has a higher voltage rail, and it's really hard to find good quality op amps today that have those high voltage rails. In the semiconductor industry, you'll find certain companies that have their processes, their wafers or semiconductors that they design to, that have certain restrictions, like they're only good up to 20 volts or 30 volts or something. So sometimes you find different kinds of chips, you know, might be voltage regulators, something like that, that they just don't, they all fall within a certain voltage range, and that's because of their processes. With op amps, it's the same kind of thing. So you have Analog Devices putting out some really good op amps, Burr Brown doing that. Those are some of the companies that have been around forever. They've been bought up by other companies now, but they still have that really great name. Well, I think maybe also because they were bought up by other companies, some of those higher voltage processes, they're just too expensive. They didn't sell a lot of them, so you just can't really get too many of them anymore. The other problem is the specific one I was using was a 2604, the OPA 2604. That had two 604 op amps in it. And I guess some people were, it's almost like overdriving it. They overheated. And so Analog Device thought, well, let's discontinue that because, you know, we don't want to get a bad name from that. So that's, you know, my take on it. For audio, they're awesome. So I really like those parts. Well, what I can do is I can use two 604s on a little board that plug into the socket where the 2604 went. So that's my fallback. But I think I have some 604s that will work now, and I'll test that. We'll do a separate video on that. Today what I'm doing is I decided to do a quick video showing you where I am with this, what it looks like. And by the way, this is what I think I was referring it to as a 20 watt Class A amp. It's actually capable of more wattage because of the higher voltage rails that I'm using for those op amps. And to accomplish that, what I had to do was these diodes right here, which I'm going to show you with this camera right here, because I just thought this might be an easy way to do some of these videos. So, alright, so see these diodes right here? There's two Zener diodes right there on top of each other. There's two right there. You can see those, okay? And what those diodes are doing is I wanted to get as close as I could to the maximum voltage rails of these op amps. So the op amp is sitting right over here, and it's in a socket. And this is a socket within a socket, if you can see that, because anyway, that's another discussion. But what I found was the one socket was kind of iffy, and so the big fat legs of the other socket kind of took care of it. I think it's because I tried so many different op amps that I kind of wore out their original socket, and that's what I'm going to replace over here. Okay. Then I also put these caps in here. These caps are really awesome capacitors. They're Kemet solid tantalum caps, so they're poly caps. They have really good ESR, and it's what I like about is it's consistent over temperature. So I put those caps in there, and those caps are for the voltage rails. There's two different voltage rails being set up, right? And one of the caps is like the front end of the regulator, and one of the caps is on the other side. You know, I have a SPICE schematic of this in microsim that I simulated this circuit, so you can see the capacitors in that schematic. Okay, but I wanted to grab another board. So this board here is another one of these Class A amps. I bought a couple sets of these because I want to build a couple more amplifiers. I really like this design. It's super neat. Really great at the low end and very flat. I've done some Borbede plots. I've done a bunch of videos on these, so you can go look at that. When I get this all done, I think I'm going to compile just one quick video. Well, maybe not a quick, say a quick video, right? But what I'll do is I'll try to show different measurements quickly. You know, I'll show you the setup one time probably, and then so I'll just try not to talk too much like I'm doing right now, and I'll just show a bunch of videos. But yeah, so that's what this guy looks like. Comes in the plastic wrap, if you've seen these, and they have these heat spreaders. You know, I call them heat sinks too because they do sink away heat, but you know, some people like to call them heat spreaders because it's kind of more precise because they are spreading the heat like a heat sink, but then they actually go on to a heat sink like this big guy. So these heat spreaders right here get mounted to the heat sink like that. So then there's some space between them. Now you can see how packed this design is, right? I mean, this is crazy. I got a toroid transformer. I got these 10 millifarad capacitors, 4 of them all together, 2 per rail. And now, look, here's a little ground wire right here going down to the chassis. This is for the input safety ground. But I have it going through a choke because I actually wanted to filter off some high frequencies off of that. And the other thing you might be able to see down here is the little connectors I use. Instead of the twist ties, I use these guys here. I really like them. You can kind of see down there what I'm talking about. And you can see the probes from a differential probe going up my mix sig. Hey, there I am, reflection. But I'm using this DP750-100. I'm moving this. I checked out this side just to take some measurements, but then I'm going to go over to this side. I have to repair it, okay? I have to get the op amp back in there. And part of what happened, I don't know, it was chicken and egg kind of thing. I was checking the voltage rails and that, and I might have shorted something here that took out part of the voltage regulation of the transistor, that then took out the op amp that was on this chip right here. I'm not sure if that's what happened or the op amp failed, and then yeah, I'm not sure what happened, but I suspect I touched something because I was trying to get, when the board is installed like this, I was doing some really delicate measurements down here, and I think it's kind of stopped working. I'm pretty sure I shorted something there. Yep, that's what happens sometimes. So when the AC power comes into this box, you can see it going to the transformer right here, but it has to come up to a switch that's mounted up here in the front, which is really packed in there. So I got these 2 bridge rectifiers, 1 bridge rectifier for each amplifier. So there's plus minus voltage rail come to this one. The bridge rectifier over there is plus minus voltage rail for that side. But in between there, my star ground is all kind of, there's a big bar right there going between the 2 bridges, and in that bar I have this inductor, another inductor with the wire here going down to the chassis. So that's my star ground right there, okay? And you can kind of see this little deal that I did to get the capacitors mounted. I kind of used these hose clamps, kind of oval shaped them, and clamped them with all these nuts to this thing. So yeah, it's not really the design that I'm happy about, but given this really small box and trying to get an amplifier built, it's what happened, and it's actually worked out pretty well. So that's what it looks like. The 4 transistors on the heat spreader, and you can see the capacitors, the diodes. Maybe that's a better look at the 2 diodes right there. Yeah, so there you go. The other modification I did, so up here where the op amp comes in, I'm going to do a little cleaner job on this wiring here. This is the input cable, the input signals coming from up here. But yeah, so I'm going to clean this up a little bit. It's a shielded cable. It's a nice quality shielded cable. So yeah, I'll clean this up. That's part of why I brought it back, is to kind of do some cleanup. I was just getting it so we could do some testing, see if it was worth spending more time on, and it is. It's a great amp. Now, see this socket? You can see the light coming through those, right? But it's not coming through all of them. So to repair that, so here, I'll show you what I'm going to do to repair that, okay? What I do is I take this, go like this. If you haven't seen these little vacuum nozzles, then you push the thing and this plunger pulls back on a spring and it causes a vacuum that pulls solder into that. Using that technique or this braid. So I started off the braid, and you can kind of see maybe a little bit of solder on the braid down there. But I think I'm at the point where the air gun's going to work better now. Alright guys, so what I do is on these other, I've been cleaning these up, and that's when I decided, hey, maybe I should just film something to show you guys. I put the soldering iron in one of the pins, and I suck it out from the other side. And then I check to see if it looks clear, and that one is almost clear. The other ones, I actually, well, maybe it's because I wasn't doing it in front of the camera, but anyway, you heat it up nice and hot, and then you suck it, and you put the thing right against the board, and yeah, it does a pretty good job of opening it up. It might work actually better if I remove the soldering iron real quick, but I'm using the soldering iron to kind of push the board against the vacuum thing. But the reason I say it might be better to remove the soldering iron out of it is because when it's trying to suck it through, the soldering tip actually, doesn't let the vacuum go work quite as well. So, but yeah, I'm just going down through and cleaning them all up. And I think I got 2 more to get. And then that's the thing about these through-hole sockets and these boards. Sometimes this seems like a quality board. The pads are kind of small, so not the holes, but the pads themselves around the holes. So you don't. It's hard to get a lot of heat on the pad or on the through-hole because of the small pads, and that's just a matter of whoever designed the part just used too small of a pad. So you have to be a little bit careful because you don't want to suck the pad off the board. But like I say, I think the board is made with 2-ounce copper, which helps hold the pads in place, and yeah, that looks pretty clean. So I can see air through all of them now, and I'll kind of show you that. The little trick I use besides just using natural light is to use a flashlight there. And with the flashlight there, you can kind of see all the holes, so it looks like I've cleaned it out. So even when they're clean, if the holes, like in this case, are made just barely big enough to get these pins through, if they're not super clean, which it looks like they are because it went through, then, God, sometimes it's still hard to force them in there. So yeah, it really helps with the suction device. If I had a board in one of those little, I have some of these, I'll have to show you, but I got to get my bench set up where I can do soldering, rework kind of stuff. So this is kind of behind the scenes. I got my coffee. Yep. Been drinking it all morning. And yeah, you're not supposed to do that at a bench, right? Well, this is my bench, so I can do what I want. Yeah. I'm not powering things up, so I'm not worried about being shocked. And when I am powering things up, I'm not touching anything, so I'm safe there too. Now, as far as my soldering goes, you know, I did a review on this, but I never posted it. It's, you know, I guess I should do another one on this. These are great soldering stations, low cost, they work awesome. And I bought this, so I think I bought this station separately. So it has the nice thing where you can adjust the angle of that. It's got a little carry handle. It's got a little thing where you hold the solder. And I guess I'll take a close-up picture of that with this little GoPro. So yeah, you can see the little station there and how the solder spool drops in there. So it works pretty nice. And I got my little sponge there. It's kind of funny. I worked with a guy one time who didn't believe in using sponges. There is a myth out there that people believe in. But yeah, sponges are great. So I use a little bit of everything. I use this guy to tin my soldering iron. I've had this for years and years and years. And it's funny how it just lasts and lasts. So it's crazy. And then, yeah, this is a nice suction thing. And then I have this guy here. So, you know, sometimes it helps to clean your tip with that. So I use a combination of that, the wet sponge, and for tinning, I use that little guy there. So, yeah, here we go, guys. Been a crazy weekend. Been spending here in the lab working on this stuff. But it's fun. It's my hobby, right? And it's kind of how I started this channel. Just taking along you guys with me. So I hope you like that, and I hope it was kind of fun to kind of see what I do on a weekend besides putting together the videos. So this little chip here, you can see the pins right here, how those nice machined gold tipped. This is a nice socket, so yeah, you can see how they all just came in there. They just barely come out far enough, probably 100 mil, I'm guessing, to be soldered. But yeah, so it's a nice socket. Then I can plug in my chip, and hopefully that chip will work. It's nice to solder the chips in, but you gotta be really confident. It's nice to have a socket so that if you are swapping out chips, that you can experiment. But that's why you like to use these gold-plated machined, the round sockets versus, like you'll see the tin type sockets that have the flat leads. These are round leads, so you'll see the flat leads, and then the little spring where the chip goes in. Sometimes they're just like little leaves that spread out like that. Where this is more of a gold-plated round chip with, I think there's a little tin thing down below. I'm not sure, but anyway, the blades of the chips are kind of flat and they kind of cut into the round socket. But once you've done that 10 times, which I was doing a lot of it because I was trying different chips, and when I finally decided just to bring the voltage up even higher and change the voltage regulation on this circuit here, that was kind of the thing. The other modification I did on the board was I changed a resistor on the input of the op amp to add more gain. So I have a lot of gain. And what that does for me is I can use turntables, whatever, directly into this without using a preamp. And it's Class A amp, so it doesn't need a lot of signal to make music. So yeah, that gain, it doesn't hurt anything. Sometimes you don't want to put a lot of gain in one stage, but in this case I'm using this op amp, which is really just a bunch of transistors in there, right? And so it's okay to have, I don't have like tons of gain. One of the problems with like a lot of gain is that an op amp, if you look at the Borbede plot, it starts off the high DC gain here, and then over frequency at some point it starts to drop off. And let's say down here in the curve somewhere, let's say you want 30 dB or 20 dB of gain, wherever it is. If you look at 20 or 30 dB, come over here, you go, wow, that's 100K. Oh, that's okay for audio. That'll work for me. So it's fine. My gain product is what that is my bandwidth and my gain. I'm fine. I've done multi-plots on this and I go out to 100K. This thing is really, it's got a nice servo loop. Anyway, look at my other videos where I show the simulations of this thing, and I thought maybe I should do some more simulations of that circuit. I basically introduced it, showed how to use it, and I kind of left it at that. But yeah, let me know. So behind the scenes, I got my iPad here. I'll watch YouTube videos sometimes, or I play music or whatever. And yeah, so I just sit here, and so I'm going to clean up this part of my lab here, put the bench in, and move the bench. I got another bench right here, but I'll move things around. So yeah, I'll have a place to do soldering and have all this stuff set up at a nice station. So, okay guys, hope you liked this little kind of behind the scenes video on my Class A amp. Let me know. Might have been boring for you. Might have wanted more.